Hello, this is another online teaching series from our department, and this is for sixth semester. And in remote sensing, today we'll discuss about the characteristics of the sensors. So sensors, as you know, these are the mechanical devices that are used in satellites to get different information from the Earth surface. So what are the resolutions, or you can say the characters of the sensors? So there are four different types of resolutions based on which a sensor is characterized. The first one is the spatial resolution. So the spatial resolution, it refers to the size of the smallest possible object that can be detected by a sensor which is placed in a remote sensing satellite and which is revolving in a low Earth orbit. Now it depends on the instantaneous field of view, or which we call the IFOV, and the height of the satellite orbit. It tells the pixel size on the ground surface. As you know, the satellite imageries, they are the raster images, and they consist of pixels, and the pixels are the smallest or the fundamental units that constitutes a image file in a digital file system. Now, what is the difference between the raster and the vector images? Now, for example, here you can see that these are the administrative boundaries of the Indian subcontinent. Now this is a vector image. Now no matter how far I zoom, these lines or these letters will not tear. They the resolutions of these images will remain intact. This is because these are not created from pixels. These are created from mathematical formulas that constitutes this image, and the computer reads, or it manipulates the curves that can be created from that particular mathematical equation. So these are vector images. Now if we compare this vector image with a raster, here you can see this is a raster image, this is a list tree satellite image. After some sort of zooming, the image will tear and you will not able to differentiate the objects. But from a higher distance, you can able to differentiate the water body. This is the water, this is a river, and these are some channel bars, and this red area, it indicates the vegetation, and these are the human settlement areas. But after some zooming, you will get the pixels, individual pixels that constitutes the image. So the satellite image may consist of several pixels. Now based on the amount of pixels and the size of the pixels, the resolution of the satellite imagery varies. Here the single pixel, it represents 250 kilometer, and here a single pixel represents 100 kilometer, and in this picture a single pixel constitutes 28, it represents 28 kilometer. As the pixel size becomes smaller, the resolution of the image becomes better and better. So the spatial resolution of a sensor is the ability by which it can produce smaller pixels that can be useful to differentiate small objects in a satellite image. Now what is the spectral resolution? The spectral resolution describes the ability of the sensor to define the fine wavelength range. Now every object which is present on the Earth's surface, it emits or it reflects certain type of wavelengths, and if the sensor is able to detect the finest variation in the wavelength emitted or released from the surface, then it will able to detect, or it will able to differentiate the objects in a much better way. Now the spectral resolution, it defines the ability of the sensor whether it can be able to differentiate the finest variation in the wavelength of the radiation that has been emitted or reflected from the objects that are located on the surface. Now, if the ability have a spectral resolution, then we can say that it has the capability of differentiating the finest variation of the wavelength, or finest variation in the wavelength of the radiations emitted or released or reflected by objects located on the ground. Now the third one is the radiometric resolution. It is more or less similar to the spectral variation, in which we have seen that the sensor have the capability to differentiate the finest variation in the wavelengths or in bands. Now in case of radiometric resolution, the sensor have the ability to differentiate, to discriminate the energy of the wavelengths that are emitted from the objects. Now there are two examples. In the first picture, the image is utilizing an 8-bit memory allocation system, and in the second picture you can see that the image is using a 32-bit allocation system. Now it means that the pixels that constitute these images, every pixel has a memory allocation. Now if we provide 8-bit per pixel, then every pixel is capable to record 8 bit of information. Now if we increase this memory allocation provided to every pixels of the image to 32 bit, then the pixels of this enhanced image, it will able to record much more information than that of a 8-bit image. Now the benefit of providing more memory to every pixel is that the image or the pixels will be able to record more and more information about the contrast, about the brightness levels. So definitely the image will be more sharper. So here you can see that these are two satellite images taken at two different uh, radiometric resolution. The first one is a 8-bit image and second one is a 32-bit image. Now you can see that in 32-bit image the objects become more sharper and you can differentiate the objects more easily than the previous image, because here you can see the coastline as well as the road sections and the small settlement areas, houses and buildings are visible, but here they are they are blurred and the visibility or the sharpness of the objects is very low. So this is the benefit of providing more memory to the image, and that is the radiometric resolution. Now it depends on the sensor whether it is able to produce a 32-bit image or it is able to produce a 8-bit image. So if you increase the radiometric resolution, then you have to increase the capability of the sensor so that it can produce 32-bit images. Now the last one is the temporal resolution. Now the temporal resolution, it refers to how often it records imagery of a particular area, which means the frequency of repetitive coverage. Now the temporal resolution, it depends on the capability of the satellite or the capability of the sensor to take pictures of a particular area in a repetitive manner within a very short period of time. By that way, we will be able to differentiate the changes that has been brought to the area. Now here you can see this area has been captured several times in the same year. This one in May, this one in July 2nd, and this one in July 21st. So the variation uh, or the change that has been brought to this particular land can be recorded because of this temporal resolution. So so we have been able to record this variation because the it was this area has been imaged several times within a very short period of time. So here you can see this now the gradually the land has been cleared, and maybe it is again ready for recultivation. So this type of changes that has occurred in a very short period of time in a particular area can be recorded um, if the sensor or if the satellite can able to do that in a very repetitive manner within a very short period of time. So it is the temporal resolution. So these are the four types of resolution that characterize the uh, satellite sensor used in the remote sensing satellite.